Hey guys, Joe back at it once again with some OCR FSMQ, and today I am showing you my attempt at this year's paper, the June 2016 FSMQ, which happened today at about 1 o'clock. Oh, it was a bit of a stinker, wasn't it? I think pretty much everybody didn't enjoy it. I didn't enjoy doing it, to be honest. It took a lot of hard work for me, and I know my class are definitely gutted at it, and going by a lot of your comments and people on Twitter, a lot of people are very, very disappointed with how they've done. And it is a very, very different paper. I regret saying yesterday that was going to be predictable. I've probably jinxed it for everybody. But these are what I got. But a huge disclaimer here. They may not be right. They may all be wrong, in fact. So, you know, take every answer that I give with a pinch of salt. I'm not saying these are the right answers by any stretch of the imagination. And some of the questions, you know, one of the questions I didn't really have a clue on, to be honest, but I gave it a go, and hopefully I can put some of your guys' minds at rest with some answers ringing bells. But here we go, let's get into it. The first half of the paper wasn't too bad, so here we go. Question 1, solve the inequality 1 minus 2 brackets x minus 3 is greater than 4x. So what you do there is expand first, and you get that. And there, be careful of your double negative there. Minus 2 times minus 3 is plus 6. Rearrange and you get 7 is greater than 6x. Therefore x must be less than 7 over 6. 3 marks in the bag so far. Looking good. Question 2 then. The gradient function of a curve is given by dy dx equals 3x squared minus 4x plus 2. Find the equation of the curve given that it passes through the point 1, 3. So to get back to y, we have to integrate with respect to x the name of the gradient function. So we add 1 to the power, divide by the new power. I've just cancelled straight away because I'm trying to get this out as quick as possible. Don't forget your c there, you must have your plus c. And now we're given some information in the question to finish it off. So we set it equal to 3 and put a 1 through. Therefore your c is a 2. And your y should equal x cubed minus 2x squared plus 2x plus 2. Question 3. Find all the values of x in the range 0 to 360 that satisfy 3 sin x equals 4 cos x. So divide both sides by cos x, because it's bad news if you've got two pieces of trig, you can't solve it. So we divide both sides by cos x, so you get 3 sin x over cos x equals 4 cos x over cos x, which is 3 tan x equals 4. Divide both sides by 3 and you'll get tan x equals 4 thirds. Do the shift tan of that and you get 53.1, but remember, tan solutions come every 180 degrees and you want to go all the way up to 360, so it's 233.1 as well. Question 4 then, you were given that the f of x equals x cubed minus x squared plus x minus 6. Show that x minus 2 is a factor of x out of f of x. So we'll shove a 2 through, so we'll get 2 cubed minus 2 squared plus 2 minus 6, which is 8 minus 4 plus 2 minus 6, which is 0, therefore it's a factor. And then what you do here is you divide x minus 2 into the cubic, so you know, you'd get your bus shelter like that, and you'd say x minus 2 and then the cubic, and you'd say what do I times that by? To get that you'd say x squared, and you should end up getting a quadratic on the top of x squared plus x plus 3, and then x squared plus x plus 3 cannot be solved, therefore it's only got one real root, which is 2. Question 5 then. John draws a triangle ABC with sides AB equals 12, BC equals 16 and AC equals 20. However, he can only measure the sides to the nearest centimetre. State the smallest possible length of AB in John's drawing. Well, I did this wrong at first. I calculated the perimeter of the triangle. But the smallest possible length of AB is 11.5, because that is the smallest number that will round up to 12. Now, to make for the second part, hence calculate the largest possible value of the angle B in John's drawing. So I think I may have done this wrong actually. Now I'm coming to think of it. because I thought was the largest possible angle. So to make the largest angle possible, I would need the smallest possible sides. Can't spell, so that should be an S there. Possible sides connecting to the largest possible side. So there you go, I did that. But in this case, that would be, let's think, so AB equals 12, so that's A. Yeah, that's going to be B, and that's going to be C. So I'm assuming it's this angle here that we need to work out. So we need that to be smallest, and that to be smallest, and that to be the longest. So that should be a 16.5. I'm going to try and salvage that here. So that's 11.5 still, and that's going to be 19.5. So what I did there is use the cosine rule, which is cos x equals b squared plus c squared minus a squared over 2bc, and then obviously that would become a 16.5. That would be still that. No, it wouldn't. Hold on. Oh. Anyway, I should really stop this recording, but I'm not going to because I feel like I need to get this out for you guys. So it's going to be 19.5 squared add 11.5 squared minus 16.5 squared over 2bc, which is 2, 19.5, and then 11.5, like that. And I'm going to quickly do this on my calculator now. So 19.5 squared and 11.5 squared minus 16.5 squared over 2 brackets 19.5, 16.5, do the shift cos of that, and yeah, it's 68.1 degrees apparently. So if you got that, and that rings a bell, but I have just rushed through that, so that's probably my first mistake of the day. That's what I did. So number 6 then, a lot of people had problems with this one, including me at the start. It took me a bit of time to get my head around it. 2 cars are initially at rest facing in the same direction on a straight road. Car A is 100 metres ahead of car B. The 2 cars start from rest at the same moment. Car A moves with constant acceleration 1.5 and car B moves with a constant acceleration of 2. So you set up your SUVAT like that, you list your variables. So S is going to be unknown. U's a 0 in both cases because it starts from rest. A for A is 1.5, A for B is 2, and T is T seconds. So the distance of the car, I said S equals UT plus a half AT squared. So for A, that must mean S equals 0.75 T squared, and for B, that must mean S equals T squared. Now, if they're at the, well, hold on a second actually, but A starts 100 metres ahead of B, so B equals S plus 100 equals T squared, therefore S equals T squared minus 100. Now if they're overtaking each other, they're kind of on the same path, therefore we can set what S is equal to each other and we'll get that, which rearranges to that, which is that, and that puts a smile on my face because T's are 20. And then I'll stick that back through one of my equations and I'll get 300 metres. Quite a lot of work there for 4 marks, so there might be an easier way of doing that, but that's the way I did it. The speed of car B at the moment when it overtakes the car, well, we've worked out with T value, so V equals U plus AT, V equals 0 plus 40, V is 40. Question 7. As you can see, these are my scribblings. This is a horrendous diagram. I couldn't get my head around it. It's an awful diagram. I don't know what OCR were thinking. An extension to the roof of a house is shown in the diagram below, like that. The ridge CD and the lines AB and PQ are horizontal. PQ is perpendicular to CD, M is the midpoint of AB, the line PM is vertical. Right. So, PQ is perp to CD, that means QPM is a right angled triangle, so if I just show you where my pencil marks were. There you go. This is the triangle here. So it comes along and goes down like that, and then the dashed line across. That is a right angle triangle. That is 45. I don't know where they got 1 mark from this, but never mind. And that is X there. It's all to do with that being perpendicular as well, but it's a very, very bad diagram. So, you know, don't worry if you didn't get this right. I don't think a lot of people will have. But PQ is 2 tan 45 by my diagram. Therefore, PQ is a 2. And the angle PBQ is where I've drawn a theta here. So, through Pythagoras, I worked out that PB squared, so that's this line here, is equal to 1.5 squared add 2 squared. So PB must be a 2.5 then. And then I can do the shift tan of 2 over 2.5, which is 38.66 degrees. Question 8 then, write down, oh dear, this is the one I didn't have a clue on. Write down the binomial expansion of 1 plus delta all to the 3. Well, first bit's easy, but it was a shaky question for me. I've just uploaded me handwritten solutions here, so obviously you've got your C numbers on the left here, and then the person on the left, so as you see it, starts high and then dies, and the person on the right, which is delta, and I can't really draw delta if the truth be known, starts low and then grows, and that equals that. So that is the answer, I think, of part 1 for 2 marks. Hence explain. Well, if we have, well, that's meant to say delta. So if we have delta to the n, as n gets bigger and bigger and bigger, obviously delta will get very, very small very quickly because it's going to be less than 0. So therefore it'll become almost irrelevant. So the only ones we'll actually have are these solutions here, where delta is only to a sensible power of 1 or 0. So you'll get 1 plus 3 delta. That's how I thought of it. That might not be right. And this last bit, I'm just going to put it on there. I just substituted this into this. No, sorry, not this. I substituted this into this and got that, and then I knew that this here was this, and then I expanded, tidied up, and I got an answer of 0.050, but the fact that it's to 3 sig figs put us off a little bit, thinking that that might not be the right answer, but that's what I did. Tell us what you guys got down below. I really don't think that's right. So yeah, I would have dropped maybe 5 marks on that question alone. Question 9 then. A curve has the equation y equals xq minus 3x squared minus 3x plus 4. Points P and Q lie on the curve. The coordinates of P are 3 minus 5. Find the equation of the tangent of the to the curve at P. Lovely question. Follow that one. So do y dx, power to the front, knock 1 off the power. When x equals 3, do y dx equals 6. Y minus b equals mx minus a. Drop in your numbers like that. Expand, tidy, job done. The tangent of the curve at Q is parallel to the tangent to the curve at P. Find the coordinates of Q. Well, it's parallel, so the gradient equals 6. So set with gradient finder equal to 6, which is dy dx, by the way. That's what dy dx does. It's the gradient finder. That's a common factor of 3 there, so I divide throughout. Rearrange, and that's a lovely quadratic because it factorizes to that. We're going x to be 3, which is brilliant because that's that there, so I know I'm right. And my other value of x equals minus 1 gives a y of a 3, so q must be 1 minus 3. So a nice 7 marks to get for question 9 there. Question 10, I was dancing around the room when I seen that this was the linear programming question. 3 inequalities, and yeah, you've just got to plot the lines. So you are going to see for the first time my hand-drawn linear programming graph. So that is that there. Obviously I've tried to shade out as best I can, but pencil doesn't really pick up on the scanner very well. So there's me region R, and then I drew my objective function, which is 7 plus 4x, and the way I did that was let 7x plus 4y equal 28, because that's a number friendly to both of 7 and 4. Therefore x must be a 4 via the cover-up method, y must equal 7. So I went in a parallel fashion after drawing that objective function on, and the maximum I got was the one I've put a ring around, and that was a 3 6. Therefore my profit must be 45 because I've put it back through the objective function there. 7 marks, not too bad. Question 11 then, another question a lot of people have had trouble with from what I've seen. A lot of people commenting they wanted to be in the car that was going towards this train on this question, which I actually found a little bit funny. But here we go. A railway track runs due east-west and is crossed at O by a road running due south-north, as shown below. The crossing has no barriers, so OCR being a bit morbid here. Initially, a train is at point B, 400 metres from O, and a car is at point A, 100 metres from O. The train is travelling at a constant speed of 25 towards O, and the car is travelling at a constant speed of 20 towards O. At time t seconds, the train is at the point Q, and the car is at the point P. So, OP must be 100 minus 20t, because he's going towards there, so therefore each second that passes the distance is going to get smaller, so it's minus 20 times your t. And OQ, similarly, it's going to be 400 minus 25t, because as time goes on it's going to get closer and closer to the origin, so that's why we're doing that. The distance between the car and the train at this at time t seconds is x meters. Find a formula for x squared in terms of t. Give your formula in the form x squared equals a plus bt plus ct squared, where a, b and c are to be determined. So I just drew myself a triangle. I labelled me OP and me OQ on there, and I just called that x, a distance x, because that's the distance between the car and the train. And then through Pythagoras, I squared everybody up, which got awful, and it ended up being that. So that's me A, B and C. But you know, that's not a convincing answer, so you know, don't quote us on that one. Differentiate this formula with respect to t and find the time at which x squared is a minimum, hence find the shortest distance between the car and the train. Right, so if we differentiate both sides with respect to t, we get dx squared dt equals power to the front, so it's going to be minus 24,000 add 2050t. It's a min, so we set it equal to 0, so we get that. Taking people over the other side, you get that. So t is that, and I was thinking this is definitely wrong. So I put that back in to me x squared function, and I got that, which is that. So my shortest possible distance between them is apparently 171.8 meters, but yet again, I don't know the answers to this paper, so that could potentially be wrong. But if it rings a bell, let us know down in the comments. And part 4, show that the car passes point O before the train. So if the car travels at 20 meters a second, it'll get to O in 5 seconds, because it's 100 meters away. And if the train travels at 25 meters per second, it'll get to O in 16 seconds. Therefore, the car travels quicker. That's pretty much that. Question 12 then. Another nice question actually to have. No, question 12. So the line L1 has the equation 3x minus y equals 1, and the point P has the coordinates 8, 3. Find the equation of L2, which passes through P and is perpendicular to L1. So y equals 3x minus 1, just rearranged, so therefore your grad's a 3, and therefore the grad of the perpendicular line is minus a third. So y minus b equals mx minus a. Put in your numbers. There I would times throw it by 3 and get that. Changing everybody's sign in the bracket. Rearranging, and I get that. So then, part 2. Find the coordinates of the point Q where L1 and L2 intersect. So if I know that, hold on, let's have a look. Y equals 3x minus 1, I can paste that in for this y here. So that's what I did, like that. And then I expanded, tidied up, big smile on my face because an x is a 2. Putting that back through, y is a 5. Therefore, q is a 2, 5. Find the length of PQ then. PQ equals the square root of that. Add that should be. And PQ's root 40. Therefore, PQ is 2 root 10. Part 4, write down the equation of the circle that has centre P and the line L1 as a tangent. Well, I just wrote it down like that because the centre is that, and this PQ would be the radius, because if you think about the circle, I think I draw a diagram in the next bit anyway, but that is PQ, that's P, and that is Q there. So that must be the radius. Therefore, that is the circle equation. So there's the final bit. There's me diagram, me lovely diagram. There's been a couple of questions like this. Find the equation of the other line that is tangent to the circle and is parallel to P. So I just looked at the differences between that and then went along to that and said, well, the distance between 2 and 8 is 6, therefore it must be 14, and the distance between 5 and 3 is 2, so that must be 1. And I did y minus 1 equals 3x minus 14, expanded, tidied, ended up with that. Question 13 then, a lot of comments about this question as well, the buns and the loaf of bread. It took me ages to get the second bit of this. But write an expression for the number of packets of buns that can be bought for £5.40 and an expression for the number of loaves that can be bought for £5.40 if a loaf of bread's x plus 75 and a bun is x. So buns are x, loaf is x plus 75, therefore your buns must be 540 over x and your loaves must be 540 over x plus 75. The number of packets of buns that can be bought for 540 is 5 more than the number of loaves that can be bought for 540. So 540 over x, which is your buns, must be your loaves plus 5 because it's 5 more. Times throughout by x plus 75 to get rid of the horrible fractions, and you get that. Expanding and tidying, you get that, and that's great news because this 540x is going to go, and you're left with that. Dividing through by 5, you actually get that, and I honestly, I celebrated when I seen that and thought, phew, what a question that is for 5 marks, definitely well deserved. This isn't a well-deserved 5 marks. Solve this equation to find the cost of the packet of buns and the cost of loaf of bread. Now, if you couldn't get part B, you could use that equation and factorise it and get that. Or you could have used quadratic formula, whatever you like. So x is a 60, because obviously you kind of have negative money, unless you're in debt, but let's not talk about that right now. So x equals 60. Therefore your buns are 60 pence and your loaf must be 1.35. I really don't see how they got 5 marks from that one, but I'm not complaining. Voice went a bit weird there. Part 14 then. Last question. Thank goodness. The equation of the curve is given by y equals x cubed plus ax squared plus bx plus 1. The points P, minus 3 and 7 and Q, 1, 3 lie on the curve. Form 2 equations in A and B. Solve these equations to show that A is a 3, B is a 2, minus 2. So we've been given some information. If we set it equals 7 and put minus 3 through, we'll get that. So 9A minus 3B is 33. Similarly for the other equation, I get that. I'm going to times the bottom one by 3 to get that, and then add this one and this one, and get 12A equals 36. So A must be a 3. Bing, 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 bing. And then put that A back in, and you get B to equal minus 2. Bing, 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 bing. 4 marks for that. Not too bad. Part 2, find the midpoint R of the line PQ and show that R lies on the curve. So PQ is minus 3, 7, and P is minus 3, 7, and Q is 1, 3. Therefore, the midpoint of that is minus 1, 5. What have I done here? Yeah, shown that it's on the curve, so y equals that. So if I shove a minus 1 through, I should get a 5 out the end. Y does equal 5, therefore R is on the curve. Bag myself into the 2 marks. And this is perhaps one of the loveliest area between two curves question that I've ever seen, really. I mean, it probably wouldn't have been lovely for you guys to do in the heat of the moment, but I quite enjoyed doing this and got a very good feeling at the end of it when I got it right. So the line PQ, if we think about it, so it's going to be the area between the curve, the cubic curve, and this line, which is PQ. So PQ has a gradient of back take back over front take front, which is minus 1. Y minus 3 equals minus 1 x minus 1, which is that. I was running out for space here, so I'm skipping a couple of steps, but you should be able to keep up with that. So y equals that. This is for the third part, by the way, because we're looking for the area. I nearly missed that when I was doing it before. So the meeting points are where that line meets the curve, which is, I haven't wrote it out, but it is up there, and we can replace the A's and B's with 3 and minus 2. Nearly there now. So trial and error got us factors of 1, minus 1 and minus 3. Once you got one of them, you could divide it in and then get a quadratic and solve it. But they're the 3 meeting points of the curve, which makes sense because you've got one positive, which is here, and you've got 2 negatives here and here. Right then, so now I'm ready to go. So A1, the ceiling to the floor, is the curve, because that is that, minus the line, which is that, which ends up being x cubed plus 3x squared minus x minus 3. So therefore, if we integrate between minus 1 and minus 3, that curve, add 1 to the power, divide by the new power, you get that. Shove a 1 through, shove a minus 3 through, that should be a minus 3 down there. And I promise you, you get 4. Try it now if you want, turn your calculator on, you should get 4. A2, the ceiling take the floor, it's actually going to be the line take the curve this time. So it's going to be that take that, which is going to swap everybody's sign around. So therefore, our integral is that between 1 and minus 1. Add 1 to the power, divide by the new power, you get that. Again, that should be a positive 1 up there. Put a 1 through, put a minus 1 through, and I promise you, you get 4. And I was so happy when I seen that, because A1 equals A2, and I got myself another 6 marks. But that is that for the June 2016 FSMQ paper. I'm exhausted. I am exhausted. Since about 3:10 today when I first got the paper. That's all I've been doing, put the PowerPoint together, replying to people's comments and stuff, and put that on there. But hopefully you guys have found it helpful. I was very disappointed there was no binomial distribution on there. I mean, me and my class have done it to death, and I think they were really confident with it, so it's a big shame that that wasn't on, but you know, it'll probably be on next year now. But they are my answers. They're what I think the answers are. Some of them will be wrong, undoubtedly, but hopefully a couple of the answers ring a bell with you, and it may put your mind at ease. But do not worry, it's the same for everybody in the country. The general consensus is that it was an awful exam. So, you know, there could be low grade boundaries. I don't want to speculate on that. It's usually about 70 for an A, but you know, you might be looking at low 60s, maybe even high 50s for an A if it's gone that bad for people. But you know, try not to think about it too much. Do something you enjoy, and if you've got 100% of what I've got, then you know, me and you would have got the same grade. Think of that. And yeah, thanks for watching, guys. Let us know how it goes in August. Obviously, I'll be taking a bit of a break from FSMQ for a year. I think I might do the 2017 paper when that comes out. Probably not straight away, but hey, I'm waffling on now. So hopefully you guys are having a wonderful day. Obviously, do something you enjoy. Take your mind off things, and yeah, hopefully that's put your mind at rest. So anyway, thanks for watching and goodbye.